Here are the answers to the PreCalculus partner test. Question number 1, it says write a rule for the equation for the transformation of shifting a graph 8 units to the left, compressing it horizontally by a factor of a half, shift it down 5, reflect it over the x-axis, and vertically stretch it by a factor of 3. So this is the reciprocal function, y equals, and you're going to, the numerator, we talked about this in class yesterday, the numerator is going to be your vertical stretch or compression, so that's the c value. Then underneath is going to be the a, and then x minus b, and then plus d. So for problem number 1, to do all these transformations, f of x equals, let's put everything in order. By shifting the graph 8 units to the left, that is going to be the x, and you're going to write, instead of minus 8, it's going to be plus 8. Compressing it horizontally by a factor of 1/2. The horizontal compression, what you do is you flip this number, you get a 2, and that's your a value. The next one, you're going to shift it down 5 units, so this is your d value minus 5, and you're going to reflect it over the x-axis, that's your c value, and you're going to vertically stretch it by a factor of 3, so it's going to be negative 3. So this is your reflection over the x-axis. A negative would be down here would be a reflection over the y-axis. Next, so this question, there are 1, 2, 3, 4, 5 parts to that. Number 2, what you want to do here is rewrite this problem as 3 times negative 1/2 x plus 4. Then what you're going to want to do is pull out the negative 1/2. That's your a value. And when you divide 4 by negative 1/2, you get x minus 8. And I always double check. I double check my multiplication. Is negative 1/2 times negative 8 positive 4? It is. Okay, so now for 2a, you need to write the parent function. You can write f of x is equal to x cubed. That's the parent function. It's the cubic function. Now, this is your a value right here. This is your b value. This is your c value. And this is your d value. So we start with a for the correct order. Since there's a negative, it's a reflection over the y-axis. Then this 1/2, you flip it, you get a 2. This would be a horizontal stretch by a factor of 2. Then you go to b, and it's a negative 8, so you're going to say 8 units to the right. And you go to the c value here. It's greater than 1, so it's a vertical stretch by a factor of 3, and then 6 units up. Number 3, and this will be worth 1, 2, 3, 4, 5, 6, and 1 for the order 7 points. Number 3, we have this graph here, and this graph consists of the following ordered pairs. So if I made a t-chart, and I always do left to right, so I'm going to name this point, this point, this point, and this point. So this point is negative 4, 0. This point is negative 3, negative 1. And then we're moving on to 0, 2. And we have 3, 2. 3, this would be 3, 2. Right here. So now we're going to use this table and we are going to do these transformations. This number right here tells you to add 2 to the x value. So if we added 2 to our x values, what we get is we get negative 4 plus 2 is negative 2. Add 2, you get negative 1. Add 2, and add 2. Then what you're going to do, you're going to take these values right here and move over here to the c value. And this c value tells you to multiply the y values by negative 2. So if you multiply these by negative 2, you get 0. If you multiply this by negative 2, you get 2. Negative 2, you get negative 4, and then another negative 4. So now we're going to plot these points. Over 2, up 0, which is that point. So that's our start. And then I would connect the next dot. So go over 1 and up 2, which is right here, and connect it. So you don't lose track of where you're going. So we did these 2 points. So then we have 2 negative 4, which is right here. And then we want 5, negative 4. 2, 3, 4, 5, and then 1, 2, 3, 4. So does it look like we flipped it over? We wanted to flip it over the x-axis. We wanted to stretch it, make it longer, stretch it vertically by a factor of 2, and we wanted to shift it 2 units right, and that looks good. So your answer is, I'm going to put it, highlight it. There it is, right there. The next graph, number 4. Again, I'm going to pick certain points, the major parts, where it changes course. I would start here. This ordered pair is negative 4, 1. I'm going to make a table. Starting with this point, it's negative 4, 1. Then that would be negative 3, 1. And then I'm going to move here to negative 1, 2. And then I'm going to move down here, over here to negative 1. And I've got 4, negative 1. Now to make a graph an even function, even means it has symmetry to the y-axis. If it said odd, it would be symmetrical to the origin. How do you make something an even function? What you do is you take all your x values and you change their signs. So all I would need to do is take my table here. I'm going to keep the y's the same. So 1, 1, 2, negative 1, negative 1. But all of these x values their signs get changed, reversed. So this becomes a positive 4, positive 3, a 1, a negative 2, and a negative 4. So we're going to plot these points right here, and that's going to make it an even function. So we're going to start with here, 4, 1, which is that point. And then we go to 3, 1, and we're going to connect it. And then 1, 2. And then negative 2, negative 1. And then negative 4, negative 1. Now if you were to fold this over the y-axis, you can check to see that the left and the right side would match. If I asked you to make this an odd function, you would take all of these ordered pairs and switch both of their signs. Number 5. You are asked to graph this without a calculator. So step 1 would be to factor the a value out. So you're going to write this as 2 times the cube root of negative 1 times x minus 1, and then minus 3. So we're going to make a table of values. The parent function is y equals the cube root of x. So we want to consider all numbers that we know the cube root of, like -8, -1, 0, 1, and 8. The cube roots of these would be -2, -1, 0, 1, and 2. So, step 1, and you don't need to use this whole table. If you want to, you can. But your first transformation begins here. You're going to, that's your A value. You're going to multiply all the X values by whatever. You're going to flip that number. You'll end up getting -1 when you flip it. So multiplying these all by -1, you get 8, 1, 0, -1, and -8. And now I'm going to move on, and I'm going to keep my X value going here. I'm going to take my X value now, and this is my next move. I'm going to take my X values and I'm going to add 1 to them. So if I add 1 to all these, I get 9, 2, 1, 0, and -7. Now I move here. This is my C value. I will multiply my Y values by 2. So I can multiply each of these in my parent function by 2. You get -4, -2, 0, 2, and 4. And now the next step is I'm going to subtract 3. So if I subtract 3, be careful because I'm looking at this column right here. Subtract 3, you get -7. Subtract 3, you get -5. Subtract 3, -3. Subtract 3, -1. Subtract 3, 1. So now I am basically going to graph these points right here. So, in the shape of it, it should look like, here's the parent function. It looks like reminds me of a snake. So, over 9, this is only 8, but we're going to pretend like there's a 9 there, and we're going to go down 7, which is right there. Then we're going to go over 2 and down 5, 2, 4, 5, and over 1, down 1, 2, 3, and over 0, down 1, and over 7, 1, 2, 3, 4, 5, 6, 7, and up 1. So the shape of the graph is going to look like this. And we're done. Next one. Parent function is the absolute value. And so for the absolute value, we use -2, -1, 0, 1, 2, which results in 2, 1, 0, 1, 2. That's easy. Now, we need to take our A value out. So you have -2, absolute value, take the 2 out, the A value, and you get x plus 2, and then plus 1. So step 1, that's your A value right here. You're going to multiply all of your X values by 1/2. You flip that number, 1/2 of all these X values. So, half of -2 is -1, 1/2 of -1 is -1/2, 1/2 of 0 is 0, 1/2 of 1 is 1/2, and 1/2 of 2 is 1. Then I'm going to move on and do the other part, this part right here, we're going to add 2. Take all these and you're going to add 2 to them. So if I added 2 to this, I get, add 2, I get 1. I'm sorry, you're subtracting 2. I knew something was wrong. Subtract 2. You do the opposite. Subtract 2. So you get -3, subtract 2, -2.5, subtract 2, subtract 2, -1.5, and subtract 2, -1. Now we move on to C. C is you multiply all of your Y values by -2. So multiply this by -2, you get -4, Multiply this by -2, you get -2. Multiply this by -2, you get 0. Multiply this by -2, and multiply this by -2. And then the last thing, you're going to add 1 to your y values. If you added 1 here, you're shifting this up 1 unit, so you get -3. Shift it up 1, -1, add 1, add 1, and add 1. So, you are going to graph those points right there. Over 3, down 3. Over 2.5 and down 1. Over 2, up 1. Right there, over 2, up 1. Over 1.5, down 1. And over 1, down 3. So these are your points that you should have. Connect your dots. I will be looking at your table, and I will be looking at the graph to see if it's correct. Number 7, you're going to look at a picture and decide if it has symmetry to the y-axis. Well, this is easy. If you fold this along the y-axis, you would see it's short. So this side would not match up with that, so it's not y-axis symmetry. If we folded this over the x-axis, this would match up. All these points would match up, so that would be good. For origin symmetry, what you're going to do is look at, if you were to draw a line through one point, through the origin, to the next point, you would not get an equal segment here. The other way you could do this is, I look at this point. This ordered pair is 6, 3. If a graph has symmetry to the origin, if 6, 3 is on the graph, then -6, -3 would be on the graph. And obviously -6, -3 is not, so it does not have symmetry to the origin. Back page. How do you test for x-axis symmetry? What you do is you replace y for -y and see if you can get the graph back to its original. So in this equation, I'm going to put a -y here, and I square it, which ultimately, if you square a negative, you get a positive. So the graph returned back to its original without doing any math. So yes, this has x-axis symmetry. Circle it. Does this have symmetry to the y-axis? What you do is you replace x for -x. So I have 2 places where you have an x. So y squared, does this equal -x squared plus 3 over -x? Well, if I clean this up, this will come positive. Now, it's not back to its original state, but if I multiply both sides by -1, if I multiply this by -1, and I can float my -1 the top or bottom. If I choose to do the bottom, I could do a -1 down here, but this will turn positive, but this is still going to be negative. So there's no way I'm going to get this back to its original state. So it's not y-axis symmetrical. And for the origin, same thing. When you replace -y and -x into this equation, these two will go back to being positive, but we still have this on the bottom. And if we multiply both sides, we're still going to have a negative on one side. You're going to have a -y squared here. And here you're either going to have a -x squared minus 3, or you can have a positive x. Either way, it doesn't go back to its original, so this is a no. For the next one, number 9, for x-axis symmetry, you replace, here's your y value. You put -y, and right now, it doesn't appear that it's back to its original, but if we mathematically multiply both sides by -1, this would become a positive y, but these would all change to be negative. opposite, I should say, and this would be a no. Doesn't work. Now for y-axis symmetry, because all of these x's are even, you replace 2x, this is going to be a negative x to the fourth minus negative x squared minus 2. These will go back to its original, because these two will go back to being positive x to the fourth and x squared. So this one does work. The origin will not work, because you'll have negative y equals 2 negative x to the fourth minus negative x squared minus 2. So these two will go positive, but if we're not back to its original, if you multiplied everything by -1, you would get y here, but these would become negative, opposite, negative x, 2x to the fourth, and then plus x squared and plus 2. So this does not work. It's not symmetrical to the origin. Last question. Even means y-axis symmetry. Odd means origin. So if it's one of these two, it would not be, neither does not mean x-axis. So how do you test for y-axis symmetry? You're going to replace, where you see x, you're going to put a negative x. So you have y equals the cube root of negative x, we're going to square it over negative x. Well, in the numerator, underneath the radical, a negative x quantity squared will become positive. So you get x squared, but this is negative x. Now it's not back to its original. If we multiply both sides by -1, you'd get a negative y here, and you could actually multiply the bottom by negative or the top. Either way, I'll do the bottom. You're going to get a positive x. It's not back. So this is a no for even. It's not even. For origin, you're going to replace both y and x. You're going to write negative y. Does this equal the cube root of a negative x squared over negative x? Well, according to what's under here, that's going to go to positive x squared. And I can multiply both sides by -1 and get positive y equals the cube root of x squared over x. I'm multiplying this whole thing, both sides, by -1. This becomes positive y, and if I multiply the bottom by -1, which is fine, you get a positive x. So this is a yes. It's odd. So if it's one of these two, obviously it's not neither. It's not necessary. And that is the end. Good luck on your test tomorrow.